So I'm going to talk about imaging supernova and remnants. Last Christmas, both Larry and I were scheduled to show our images, and I prepared a presentation around imaging of the Cygnus Loop, which is a very popular imaging target and a very, very beautiful nebula or supernova, as you will see. So today what I've done is basically augment that particular presentation with information about supernovas and supernova remnants as well. So I'm going to talk about two types of targets as far as supernova imaging is concerned. The first one I haven't done much with, but you can actually in real time look at supernova events. Supernova, when they explode, could last for a few weeks, or maybe even months, and they are brighter than some of the galaxies themselves in which these stars may be. So, and there's a lot of information I'll share with you as to where you find this information about these events. And some of these pictures can be very beautiful, and some people actually take the time to do a time sequence of these over days to see the supernova come on, get brighter, and then dim down. So that is one kind of astrophotography or supernovas, if you like. I call it real time because you're actually doing an observation as you're doing this. And then there's obviously the second type, which is the supernova remnants. And supernova remnants, as you probably all know, are really a beautiful expanding remnants or remains of a star's explosion as the star gets pushed out with shock waves, and it interacts with interstellar medium along its path, and it really becomes very beautiful. As I said, I haven't done any real-time supernova events. I plan to do that, and that's why I collect a lot of information that I think maybe some of you may be interested. Just from an observation point of view, if you're not, even though you may not be imaging, doing astrophotography as such. But I have done imaging of remnants, and I've done some fairly detailed imaging of the objects in the Cygnus Loop, and I'll share that. And as I go along, I'll talk about the equipment that I've used. If time permits, Bob, maybe you can tell me if I'm running over. But I thought we could Cygnus Loop. There are parts of it which were discovered by early astrophotographers and processed by humans, and they call them human computers, if you like. And the history of that is that Mr. Draper, Henry Draper, started this. I think it was located in Massachusetts. And he took lots and lots of pictures. And when he passed away, he was a very rich man. When he passed away, his wife basically gave all those photographic plates to the Harvard Observatory, and also gave them money to take more pictures and basically carry on with the work that Draper had started. And this is where Pickering's name comes up, and you'll see Pickering's name when I come to Cygnus Loop. And Pickering employed a lot of women to do what we use now digital computers to do. And so all the ladies in his group were called Harvard computers. And these ladies don't get recognized enough. And since Cygnus Loop, there has been some contribution by some really notable ladies, particularly Wilhelmina Fleming, I thought I would just share a slide of her accomplishments. It's International Women's Day, or it was this week anyway, so I thought it'd be a good time to do that. But I'll do that if time permits, okay? Stop me if you have any questions. So as I said, there are two types of imaging astrophotography targets. The first is real-time supernovas. Can you see my my cursor moving, Bob?
Yes.
Yes.
Okay. All right. So these are various pictures of actual targets that were done. So you can see this one here was one that kind of lit up and then diminished, and there's the second one here, and this shows a sequence done over many days by a photographer. And if you look at the star just to the northeast of, or the north of the center of this galaxy, you can see it dimming and dimming out. And okay, these pictures were short, but this is one kind of photography you can do. Or you can actually look at some progenitors of supernovas, stars that are likely to explode, and create a sequence like this for yourself. And if they explode in your lifetime, well, you might have discovered something, or you can pick one of the supernovas that exists right now and follow that in real time as well. So that's one kind of astrophotography, and I'll touch on that. I haven't done this, but I'll touch on that. The second kind is the remnants, obviously. Now, there are many remnants, and the size of these objects in the sky depends very much on where they're located, how far they are, what the age of it is, what the blast velocities were, so we know at what rate they're expanding. Crab Nebula, for example, is very small, and you need a large focal length, not large, but a reasonably sized focal length to be able to see that. The Cygnus Loop itself, which I'm going to be talking about, I'll talk about many of these objects in there. It's about the size of 6 full moons. So if you put moons across here, there will be 6 of them kind of going from end to end. Vela Nebula is also a beautiful nebula. I've seen lots of pictures of it, but it's in the southern skies. So hard to image. But it's about 16 times full moon. So, a lot of people need to do mosaics of these and stick them together. And that's how you do it. Well, recently, they also found a cloud called Anterior, and that is now determined to be remnants of a supernova. It's huge. It's about 40 full moon sizes across. And so it's hard to capture all of the Anterior. But the interesting thing is it's expanding and it's banging against and interacting with some nearby objects. And so here is an interaction of Anterior with the Gum Nebula. And that creates a very beautiful image. And this is an image I would suspect it'd be in where the hydrogen is in the green channel, as Larry was showing. Maybe it's a Hubble palette. The other beautiful one that they think is the supernova is the Burner Loop. This is the Orion that you're familiar with. These are the 3 stars of the Orion that you can see up here. The Horsehead Nebula is down here. The Flame Nebula is here. The M42 that Larry showed in his picture is down here. And surrounding all that is the Burner Loop in the Orion. And that's about 20 times the full moon. So some of these objects, you need either a very short focal length that will give you very large fields of view, or you can obviously do mosaics with your own setup. By the way, there's a very beautiful, not very beautiful, but very informative presentation that Patrick Young, who's I think a professor at ASU, he gave that presentation to our club, and his presentation is on our YouTube channel and called Life and Death Among Stars about supernova. And if you want to learn about more about supernovas, I didn't know much about it. I've by the way only gotten into this game a year and a half ago, so you know, this was one of the presentations that informed me much about supernova, and you might enjoy it yourself. So let's talk about observability of supernova remnants, as I said, would depend on the environment it's in, the energy of explosion, what kind of a star it was, and how old is the supernova remnant. Now, one thing that happens is the supernova remnants even have more than the visual frequencies. So they have a lot of X-rays and radio waves and infrared, and these are observable as well. And these data are available, and people are beginning to use things like Photoshop and basically color code these various frequencies, if you like, that are observed, and create very pretty pictures. So you can, for people like me who have just a color camera, you know, visual spectrum is of interest. But if you can get the data with radio and X-ray information, then you can create very colorful images of supernova, some of the supernova remnants. So anyway, what are the supernovas and supernova remnants of interest from astrophotography point of view? The last galactic supernova, by that I mean the supernova in Milky Way, was observed about 400 years ago, and now that's called the Kepler's supernova. And it is now become fairly dark, but there's a lot of signal in the radio frequency range. So it's kind of hard to observe, but that was the last one. Typically in Milky Way and the nearby galaxy, we should see 2 to 10 supernovas every 100 years. So we are overdue for some. And in fact, recently, 27 new supernovas were discovered by radio astronomers in Australia. So just because we haven't observed them, it doesn't mean they weren't there since the last 400 years. They probably were there, but at least not observed by humans. Okay. And what's happened is for extragalactic supernovas, by that I mean supernovas in other galaxies, there's really been an increase in exponential increase in what people are finding out about them and discovering them. So if you look at the supernovas in the last 3 or 4 years, you know, that curve of supernovas found and discovered has risen very, very speedily. And this is a very good website here run by Rochester Astronomy. It's actually, I think, by Purdue, and I'll just show you the page so you can see if you're interested in following up on what the status of active supernova is. There's a list of active ones and all the past ones as well. And there is a new observatory coming up in Chile. I don't exactly know when that is going to be in operation, but they think that in 10-year survey, they'll probably find 3 to 4 million supernovas at various distances. And if you look at just the 2021 and 2022 counter supernovas, you know, there were 21,000 supernovas discovered in 2021, and already we have about 4,000 this year. And these supernovas, or let me say candidates supernovas that are discovered, normally go to this organization called CBAT, which is Central Bureau of Astronomy Telegrams, which is now, it used to be in Paris, but is now at the Harvard College. And they are basically the the organization that processes this and decides whether it is a supernova or it isn't, and then gives it designation. So when these guys find supernovas, they designate it as PSN, possible supernova. And if it's found to be a supernova, then it gets a designation SN. And normally it's PSN with a year, and then some other characteristic that define the supernova. So these are possible supernovas amongst the ones that were found, and which galaxies are in. But the interesting thing is that amateurs are really into this game of finding supernovas. So quite a few of them were found by amateurs being out in the field. And right now, as we speak, at least the list shows that there are about 38 supernovas that are observable that you can go this evening and look at them if the moon doesn't get in your way. This is the site that I was referring to. It is Rochester Astronomy. And the page is called Supernova.html. I think it is run by Peoria University. It is maintained by one guy, and he says he spends 2 hours a day on this site. But he gets information from all kinds of sources and basically puts down everything that he can find, including images that people take. So there's a wealth of information on the site on supernovas. And if you want to actually follow real time any of the supernovas, you can find out if any of these are visible in our location and follow them. Okay, what about the future? What are we looking at in the future? Betelgeuse has been dimming and brightening, and there was a lot of speculation that that is going to explode. But people feel that before that goes, there are 5 or 6 other candidates that may go. Antares is a massive red giant in Scorpius, and that they feel is probably going to go first, as is the Cornea Borealis and Eta Carinae. They think those will go first. And there are some WR stars, which are WR, I forget the name of the guys, the 2 guys that WR refers to, but these stars have very unusual spectra. And these particular stars are very, very hot and massive, and they think they are kind of very, very close to going. So here are some possibilities if you want to follow them and see if one of those explodes. Might be an interesting observation. Okay, let's look at the remnants. In the Milky Way and in the galaxy, in the local group, as I said, there should be 2 to 10 supernovas every 100 years. There are almost 300 now supernova remnants that are known. And as I said, a lot of them are really observed by the radio frequencies because their optical signal has died down. Now, as far as the targets are concerned, very good targets are the ones I've mentioned here: the crab, the jellyfish, the Cygnus Loop, and the Anglefish Nebula in the Orion. The Spaghetti Nebula is really, really beautiful. It is in the southern hemisphere, as far as I'm concerned. It's very beautiful in hydrogen, but it is very faint. And the pictures I've seen require almost 23 hours of exposure. So, I know one guy who's going to take a trip down to Chile to do some photography down south, and this was one of his targets there. It's very, very beautiful. If you can get Hubble data, this might be one of the things to work on and put it on your wall. The one in Cassiopeia is also very beautiful, but very faint. And images I've seen, 47 hours of imaging with hydrogen alpha and 17 hours with oxygen. So you got a fair amount of time investment in imaging this. And then the Vela Nebula I showed before, which is the big nebula, and it's beautiful in the southern sky. Some of the other nebulas that were bright, the latest one that was observed was the Kepler supernova in the 1600s. Now it's kind of dimmed down, and it's radio waves mostly, and you can just see whips of optical data. Same with the Tycho supernova as well. So there are, you can get the radio frequency data and do some coloring, if you like, by color coding some data, and some of these things can be beautiful. Are there any more? I mentioned the Anterior Cloud. It was discovered in 2002, but it was discovered confirmed very recently as a large supernova. It is the largest supernova ever seen in the sky, and that is because it's so close to us. I think it's only about 1,000 light years away, and so it looks enormous compared to the other supernovas, about 40 times the size of the moon. And the Cygnus Loop, I think you must have seen pictures of it, if nothing else. And I was going to target that until all my equipment went south recently, but I hope to image this when Orion is back in the skies here. And anyway, if you went to Telescopus, you'd find a list of supernovas there. And they list supernovas, but they list each nebula in the supernovas, because some of these supernovas can have multiple nebular regions with their own designations. So, you can image those. So much for the information. Now let me talk about what I've done. I don't know, Bob, how am I doing for time? I can't see my clock here.
It's 7:50, and Larry talked about 30 minutes, so you're only 20 minutes into yours, so you got to.
Okay, so I got another 10 minutes. I maybe take 10 or 15, but I'll try to be quick. So as I mentioned, these are my pictures. This is Crab Nebula. It was supernova seen by the Chinese in year 1000. They called it a guest star. It's very small by area. It's only 4% the size of the moon. And so the image that I've taken has been with a 2000 millimeter telescope and the ASI 2600 camera, brother of, or the son of the camera that Larry has. Mine is a color camera. His is a mono camera, and I use a filter. There's a combination of his narrowband filters preferred for color cameras, but much broader than the narrowband filters that he has. This is an image of a jellyfish nebula. They haven't estimated the date of how old this is. And the estimates run from 3,000 to 30,000 years. It's about 3 times the size of the moon. So it is possible to capture this with a much shorter focal length, and I use a hyperstar on my 8-inch Edge Celestron telescope, which gives me a focal length of 390 millimeters, and again use the 2600 camera from Zuo. Okay, let's talk about the Cygnus Loop, and that was going to be my focus. Here's a picture of the Cygnus Loop, and here's my image of it. And as you can see, there are various points in the Cygnus Loop that have been designated under various catalogs, and they are viewable separately. And in fact, they were discovered separately because the early astronomers were looking at these things with fairly large focal lengths. The Cygnus Loop is called by various names, and it is 6 times the size of the moon. So in area, you could fit about 35, 36 moons in this circle here. And if you look at the radio, infrared, and X-ray images, you can really see the complete circle as such. This part of the circle is not filled, and I'll talk about that later. But these pictures I have done with a different camera, the ASI 533. It's a lower resolution camera, but I've used a medium focal length on this, which is the 2000 edge with a 0.7 reducer, basically, which gives me 1400. So what I'm going to do is actually go through and show you images of the various parts of this loop. And I also give some kind of tidbits of things I found out about each in terms of when they were discovered and who discovered them, etc. Okay, the eastern veil is this dog-like creature or form, if you like, nebula form. It's got 3 parts. One is the northern part, which is like the tail. And it's got this part here, which is the bat. You can see this part here. It's called the Bat Nebula. It's really very beautiful. I really didn't quite get this done well. And I'm waiting for this to be back in our skies and have a go at it again. And then there is this southern part as well. And the discovery was in the late 1800s of this particular part of the nebula. So the Bat Nebula that I mentioned is roughly the size of the moon. And so if I was to capture moon on this image, I'd fill this up. And the blue part of the bats that you see is really the oxygen and nitrogen signal, and the red is a hydrogen signal, and that will be throughout all the images that I'll show you. This was discovered by John Herschel in 1825. John Herschel is the son of William Herschel, and William Herschel was very, very famous and really an accomplished guy. He was German-born and moved to England when he was 19 after he deserted from the army in Germany. And he became an accomplished musician, wrote 25 symphonies. In about 20 years, he cataloged more than 7,000 stars. He was really searching for double stars, and he probably found them, but he cataloged 7,000 stars. He pioneered astrospectrophotography, and he was the discoverer of Uranus, and that was the first planet that was discovered since antiquity, and also discovered 2 of its moons, and he found 2 of Saturn's moon as well. And he was prolific in terms of how much he produced, and he was a royal astronomer in England. And he got even his sister involved in astronomy. And so his son and his sister also have a number of discoveries to their name. He built himself a telescope that I'll show you, which is a mirror of about 18 inches in diameter and a focal length of about 20 feet. And here you go. That's his telescope that he used for discoveries. And he obviously was earlier than his son, and he discovered this tail here. And I've tried to find out data on what IPC may have used and what he might have been seeing with this telescope. And I can go from this circle to this large circle. I'm not really sure. Somewhere in between he should have been, I think, in terms of his discovery. So there are his possible fields of view. Okay, moving along so I'm looking at these 2 knots here, this one first and this one second. This is the southern knot, if you like. And this was discovered in the 1830s. And you can see why the whole Cygnus Loop wasn't found in one go. I mean, they were looking at really small sections of this. And again, the blue and the red are the hydrogen, oxygen, and nitrogen data. This is the northern knot in the loop, and this was found by William Herschel in 1790. Very beautiful images, really. I mean, there's a lot of energy and a lot of interaction going on between the remnant and the interstellar medium in this area. This is the picture of what's called the witch's broom, or the western whale. And these are the two knots that I showed you pictures of. So this is not a high, image taken at high focal length. This was done with a hyperstar, I believe. And this is kind of, I don't know, like a sea creature, if you like, with a head, which is called the Pickering's triangle. And Pickering, as I mentioned, was the director of the Howard Observatory, who got all the photographic plates from Draper. And this discovery was done by one of the ladies in his group. And that brings me, well, let me just give you some interesting facts. So this triangle was discovered from those photographs that were in the observatory at that time by a lady called Williamina Fleming. The other thing about this is there's something called the southern knot. You can't really see much in the optical wavelength, but in the X-rays, you see quite a lot of drama in this here. There was a shock wave that hit some kind of a gas cloud here, and that created a reverse short wave. So the X-ray images around this region are really beautiful as well. In X-rays also, this thing looks pretty spherical. And there seems to be a big gap around here in the southern region. No progenitor has been found, and they believe that this hole may have been caused by a violent ejection of a neutron star. And they have been searching for this remnant from the explosion, but they haven't found anything yet. Okay, so I'll just end with recognizing or celebrating Williamina Fleming. Believe it or not, she came from Scotland and didn't have a job, and so she was hired as a maid by Professor Pickering. And then when his male clerk failed to perform really well, he moved her into doing clerical work at the observatory. Her contributions are profound and manifold. She came up with the scheme to assign stars the letters that we use now. She developed a classification system of stars based on temperature, and cataloged about 10,000 stars in 9 years. She discovered 86 nebulae, a lot of novas and variable stars, and discovered the Horset Nebula as well, in addition to the Pickering's triangle. And like other ladies working at that time, they didn't get credit initially, and even in spite of that, I think Pickering was really good in promoting his ladies, and she was placed then in charge of some dozen or so ladies doing mathematical classifications and editing the publications of the observatory. A lot of books and articles in the earlier time frame deny any credit, but later on she was given credit for a lot of her work. And since 1899, she started getting titles as the curator of the photographs at the observatory. She became an honorary member of the Royal Society, the Astronomical Society, honorary fellow at Wesley College, and awarded a medal in Mexico. And she has a couple of publications to her name. So that's about it. I put out in there. And if you have any questions, let me know.
Am I audible?
Yes.
Yes, okay. Myself, Theorem. So I think I joined this, I think for the first time. I think Dr. Amin invited me here. So I would like to say that I think both the presentation by Mr. Larry and Mr. Amin was quite enlightening. And both in terms of, I like how Larry explained the use of filters and how different it took the images and took a nebula and explained it. And as Dr. Amin said that, images in this thing are quite clear. And I like how he explained the use of his equipment. I think it was a great insight. And coming to Dr. Amin, the entire presentation was quite fruitful, going back right from how to basically observe the supernova and what is the history behind it, what is the current status, and what to look forward into the future. So yeah, I would say thank you both the participant members, and more thank you for having me here. Thank you.
Thank you. Any other comments? All right, if not, we're done for the evening, I suppose.